Welcome, students. Today we are going to treat fraction. We are measuring on grade 7, which is the same thing with JSS 1. And we will continue in this grade 7 until we finish the curriculum to help you follow and that serially. Today we are going to treat fraction, as I've said before. We are going to review the other aspect of fraction you have treated in your previous grades. We'll look at the concept of fraction. We'll also look at the types of fraction, the main types and other types that make up fraction. And then we'll also review the addition, subtraction, multiplication and division, the ones you have treated in your previous classes. Before now, we now face the grade 7 proper as it concerns this topic, fraction. Let's now go to the board. Let's continue our lesson on the board. Like I said, today we are treating fraction. When we discuss the concept of fraction, you have already learned it before in the previous classes, which is the same thing as the definition of fraction. When we are talking of fraction, we are talking of a part of something, or that is part of an object that is divided into an equal number. And the part of this very division is taken. We now say that that is a fraction. Or in a ratio form, that part taken over the total number of the division. We can state it this way, that a part or some parts of an object divided in some numbers of equal parts is a fraction. It is the ratio of number of the parts taken to the total number of the divided parts. Example: we have 3 over 5, it's a fraction. We have 27 over 52, is a fraction. We have 9 over 24 or 32, is a fraction, and so on, and so on. Now the taking aspect of this, which is like we have 3 over 5, the 3 above is what we call numerator. And this one below is what we call denominator. The denominator is the number of equal parts that very particular object was divided. And the numerator is the part that is taken out of this total number of division. This is what we call fractions. We have different types of fraction. The main of these types of fraction, we have what we call unit fraction. We'll explain each of these. It's true, you must have discussed this in your previous grades or class. We also have proper or simple fraction. Simple fraction. We also have improper fraction. We have mixed fraction. There are other fractions. In order, we have like fraction. These orders is based on the groups. We have unlike fraction. We have equivalent fraction. Then we have decimal fraction. Let's start with the first one and explain what it means. Like I said, in your former grade, you must have discussed them. What we call unit fraction is a fraction whose numerator is 1. A fraction whose numerator is 1 is what we call unit fraction. Unit fraction. Example of unit fraction, like I say, unit fraction is a fraction whose numerator is 1. Example, we have 1/5, 1/3, 1/9, and so on. All these fractions, their numerators, each of them is 1. We call this unit fraction. We have proper or simple fraction. These are fractions, as we were told before, whose numerator is less than the denominator. The numerator is less than the denominator. Example of this, we have 2/3, 5/9, 7/15, etc. These are proper fractions, which some of us call simple fraction. The numerator is less than the denominator. Then the improper fraction. Improper fractions are fractions whose numerator are greater than the denominator. The numerator is greater than the denominator. We have an example for that. We have 7/3, 15/2, 9/5, and so on. These are improper fractions. We also have mixed fraction. Mixed fractions are fractions that have whole number with simple fraction. In other words, mixed fraction is a fraction that has two parts, a whole number and a fraction summed together. Example of this, we have 15/2, 7/3, 125/8. You can see in each of these fractions, the numerator is greater than the denominator. We call this improper fraction. Or rather, we call this. I take it again. We are talking of mixed fraction. We are through with improper fraction. So I take it again. The examples here should be 5 whole number 2 over 3. 125 1 over 2. 7 whole number 1 over 7. These are mixed fractions. Each of them has a whole number with a fraction. That fraction under normal circumstances should be a proper fraction. This is mixed fraction. These are the main fractions. Let's go to other fractions. We have other fractions. Like we said, we have like fractions. Like fractions are fractions whose denominator are the same. Example, we have 3 over 5, 1 over 5, 4 over 5. You can see that the denominator of each of these fractions are the same. We call such fraction like fractions. We have unlike fractions. Unlike fractions are fractions whose denominator are not the same. 2 over 8, 5 over 7, 3 over 4. The denominators are not the same. We call these unlike fractions. We also have equivalent fraction. Equivalent fractions are fractions whose values are the same or equal when simplified to the lowest term. I repeat, equivalent fractions are fractions whose values are the same or equal when simplified to the lowest term. For example, 1 over 3 is equal to 2 over 6, and this is equal to 4 over 12. This is equal to 6 over 18. When you simplify these to the lowest term, you discover they are all equal. For example, this is 1 over 3, and we have 2 over 6 here. We have 4 over 12, and we have 6 over 18. 2 here will give us 1, 2 here will give us 3. 4 here will give us 1, 4 here will give us 3. 6 here will give us 1, 6 here will give us 3. You can see that the value of all these fractions, they are all equal. Each of them is 1 over 3. As simplified to the lowest term, they are all equal. We call this sort of fraction equivalent fractions. We also have decimal fractions. Decimal fractions. Decimal fractions are fractions that are expressed in decimal form. They are fractions expressed in decimal form. For example, 1 over 2 is 0.5. 1 over 4 is 0.25. And 3 over 4 is equal to 0.75. So these fractions have been expressed in decimal form. We call all these decimal fractions. That is the 0.5 for 1 over 2, the 0.25 for 1 over 4, and 0.75 for 3 over 4. These are decimal fractions. These are the types of fractions. And we have also discussed previously, that is in your previous grade, you must have discussed the addition of these, the subtraction, and the rest. But we have to review it to enable you know exactly, remember what you have discussed, like I said before. So we have operations of fractions. One of the operations of this very fraction, as we are going to discuss, is reduction. We'll discuss this in detail. Reductions. What is reduction? Before we go on to the next, reduction is what we call simplifying to the lowest term. Simplifying to the lowest term. You may be given something like example, simplify 75 over 100. To simplify to this lowest term, we keep on dividing until there will no factor that will divide the numerator and divide the denominator without a remainder. We can start with the smaller number that can divide 75 and 100. 5 can do that. Or if we know what to do, 25 can divide this to give us 3, and 25 divide this to give us 4. Therefore, 75 over 100 is now simplified to 3 over 4. We have done reduction. We have reduced this to the lowest term. What do we mean by that? No factor can divide 3 and divide 4 without a remainder. So 3 over 4 is the simplified value or the reduced value of 75 over 100. That is for that aspect. We also look at addition. Addition of fraction, where we divide a fraction, add a fraction and a fraction, and so on. Let's look at addition of fraction. Addition. If I ask to add 2 over 3 plus 1 over 6. There are many ways of solving this. We can use a model of this to solve this. By adding this, that if we're using model, this is 1 over 3 plus 1 over 3 plus 1 over 6. 1 over 3 plus 1 over 3, that will give us 2 over 3. Then plus 1 over 6. And you can see that the denominators are not the same. But remember that 2 over 3 is dissenting as 4 over 6. 2 over 3 is dissenting as 4 over 6. How do you get that? We multiply 2 by 2 to give us 4, multiply 3 by 2 to give us 6. So, in other words, we now have 4 over 6 plus 1 over 6. Now we have the same denominator, which is what we call like fractions. And to do this, we add the numerator and then add since it is the same denominator, our LCM is as the denominator, which is 6. So here we have our 6 as the denominator, and we have 4 plus 1, and that will give us 5 over 6. That is in addition of fraction plus fraction, as you have done before in your previous grade. Let us look at a question like this is number 2 example. 3 over 8 plus 5 over 8. The denominator is the same, and we call this like fraction because they have the same denominator. Here the LCM is 8. We simply add the numerator, which is 3 plus 5, and that will give us 8 over 8. That will land us to have a unit value, which is 1. But where another way of solving the previous example is where the denominators are not the same. Use what we call LCM. We can solve the previous question using the LCM, and that is this way. we had 2 over 3 plus 1 over 6. We ask ourselves, what is the LCM of the denominator? 3 and 6. The LCM of 3 and 6 is 6, because 3 can divide 6 without a remainder, and 6 can divide 6 without a remainder. So 6 divided by 3 will give us 2, and 2 times 2 will give us 4. 6 divided by 6 will give us 1. 1 times 1 is 1. And we add a numerator, which is 4 plus 1, 5 over 6. We use LCM based on the denominators are not the same. That is for addition of fraction. Let's look at subtraction. Let's have this example of this fraction. Example. Three over 4 minus 5 over 8. The LCM of these two fractions will be 8, because 4 can divide 8 without a remainder, and 8 can divide 8 without a remainder. So we have 8 as our LCM. 8 divided by 4 will give us 2, and 2 times 3 will give us 6. 8 divided by 8 will give us 1, and 1 times 5 will give us 5. And 6 minus 5 will give us 1 over 8. So subtracting 5 over 8 from 3 over 4 has given us 1 over 8. That is for subtraction. If the denominator are the same, if we have 5 over 7 minus 2 over 7, of course this is what we call like fractions. Like fractions. So the LCM is 7. We now have, in solving, this is 7, and 7 divided by 7 will give us 1, and 1 times 5 is 5. 7 divided by 7, 1. 1 times 2 will give us 2. And so we have 5 minus 2, that will give us 3 over 7. That is for fraction. Let's go to multiplication of this fraction. The multiplication of fraction. In your grade 6, you did whole number times fraction. We review it, whole numbers times fraction. Okay. Fractions as whole number, and also you treated fraction times whole numbers. By whole number. When doing that, you had an example 5 times 2 over 3. When multiplying a whole number and with a fraction, the multiplication affects only the numerator and not the denominator. To avoid getting confused, you can rewrite this and say this is 5 over 1 times 2 over 3. You know, anything divided by 1 will remain the same. If I give you 5 slices of bread just for you, you consume the 5 slices of the bread because it is for you. Even when somebody is asking you, where is my share? You say, no, it is given for me, it is just for me. So any number divided by 1 remains the same. So in this multiplication, we now say 5 times 2 over 1 times 3. And 5 times 2 will give us 10. And 1 times 3 will give us 3. We have arrived at improper fraction. We can convert this to mixed fraction by dividing 10 by 3. That will give us 3 as a whole number. And 3 times 3 is 9. 10 minus 9 will give us 1. So we have 1 over 3. What did I do? This is 10 divided by 3. 10 divided by 3 will give you 3. 3 times 3 is 9. 10 minus 9 will give you 1. So that is why we now have 3 as a whole number, 1 as a numerator over this divisor, which is 3. So this is our result. We multiplied whole number with fraction. This is the same process when we are multiplying fraction with whole number. It will be the same thing we will do. Let's have example to that. If we have 3 over 5 times 2, we write this and say 3 over 5 times 2 over 1. What are we doing? We are multiplying fraction with whole number. And so we now have 3 times 2 over 5 times 1. And 3 times 2 will give us 6. 5 times 1 is 5. We divide 6 items by 5. That will give us 1 whole number. Remember 1, and that one is 1 over the denominator, which is 5. So we have 1 whole number, 1 over 5. That is multiplying whole number with fraction, or multiplying fraction with whole number. This will be our result. Now for this particular grade, we will look at multiplying fraction with fraction of different aspects. Let's go on. Fractions times fraction. Example to this. Let's have 5 over 6 times 7 over 8. So when multiplying fraction with a fraction, the numerator will multiply the numerator. That's the numerator of the first fraction. We multiply the numerator of the second fraction, and the same thing will happen to the denominator. So we now have here 5 times 7 over 6 times 8. 5 times 7 will give us 35, while 6 times 8 will give us 48. We simplify where possible. But for this very matter, there's no factor that can divide 35 and divide 48. Yes, 5 can divide 35, but 5 cannot divide 48 without a remainder. 7 can divide 35, but 7 cannot divide 48 without a remainder. And 2 can divide 48, but cannot divide 35, and so on. So when there is no factor that can divide, or if it's not possible to simplify to the lowest term, we stop there. So this is our answer to this effect. But what I want you to know is when you are multiplying a fraction with a fraction, the numerator will multiply the numerator. I mean the numerator of the first fraction will multiply the numerator of the second fraction. And the denominator of the first fraction will multiply the denominator of the second fraction. And then if it is possible to simplify, you do so. So this is for this aspect. Fraction times fraction. We also look at division. Let's look at division of fraction. Example here. Three over 5 divided by 2 over 3. When dividing a fraction with a fraction, the divisor will be inverted. In other words, you divide a given fraction by the reciprocal of the second fraction. What does that mean? Here we have 3 over 5. In this division, we now introduce multiplication in the place of this division and invite this divisor. We use the reciprocal of the divisor, which is, instead of 2 over 3, we have 3 over 2. And that will give us 3 times 3 is 9. And 5 times 2 is 10. We cannot simplify this further. So this is what we have. So I want you to remember that when dividing a fraction with a fraction, you introduce multiplication in the place of the division and use the reciprocal of the divisor. What do you mean the reciprocal of the divisor? The numerator of the divisor becomes the denominator. Why the denominator of the divisor becomes the numerator? You multiply out and then get what you expected to do. This is for division of fraction. Now let's go where the situation we have mixture, a combination of all these operations. When we have the combination, that will lead us to what we call BODMAS, where we treat it in the sequence of BODMAS, following step by step. First of all, what do we call that BODMAS? This is BODMAS. The other nomenclature one can use, but it all is in this format. It will follow this. We have B for bracket, this is off, and while D is for division, M multiplication, A addition, while S is subtraction. If it is not followed, if a question has all these operations, if it's not followed in this very way, the answer must be wrong. For example, if you are asked to solve 2 over 3 times 5 over 7 divided by 1 over 5, we follow the BODMAS sequentially. From what we have in this BODMAS, we discover that division comes before multiplication. We follow it that way. And now in our solution, we now say 2 over 3 times 5 over 7. Then we divide by 1 over 5. Remember what we said when we are dividing a fraction with a fraction. We said we introduce multiplication for the division and use the reciprocal of the divisor, which is now 5 over 1. We now multiply. Here we have 2 times 5 is 10, 10 times 5 is 50. Over 3 times 7 is 21. 27 times 1 remains 21. It has given us an improper fraction, we can simplify this to mixed fraction by dividing 50 by 21. That will give us two whole numbers. 2 times 21 will give us 42. And 50 minus 42 will give us 8. So we have two whole numbers, 8 over 21. The important thing here is to tell you that you have to follow the BODMAS. We didn't multiply first before division. If we had done that, we may get a wrong answer because we disobeyed this BODMAS. That is when we are treating combination. Now let us treat one combination that involves addition and subtraction. Let's have 4 over 9 minus 5 over 6 plus 2 over 3. Yes, you can solve this straight away the way it is, but it is advisable to collect positive together, negative together. Positive together, negative together. We have here positive, 4 over 9 is positive, 5 over 6 is negative, and 2 over 3 is positive. You now say 4 over 9 plus 2 over 3 minus 5 over 6. Even in the process, you have obeyed the BODMAS. But like I said, when it comes to addition and subtraction, you can go the way it is, but it is more ideal to collect positive together, negative together, if each of them is more than 1. And then find the LCM of the denominators. So the LCM here will give us 18. I'm sure you still remember how to find your LCM. You did that even in your primary level, that is between grade 1 and grade 6. Now this 18 can be divided by 9 without a remainder, can be divided by 3 without a remainder, can be divided by 6 without a remainder. So 18 divided by 9 will give us 2, and 2 times 4 will give us 8, plus 18 divided by 3 is 6. 6 times 2 is 12. 18 divided by 6 will give us 3. 3 times 5 is 15. So we add a positive, that will give us 20 minus the negative, which is 15, divided by 18. And that will result to 5 over 18 as our answer. No factor that will divide 5 and divide 18 without a remainder. And as such, we stop here for this very combination. Again, I remind you that this lesson is a continuous affair. We are not stopping here. We'll continue. As I said earlier, we will go through all the 7 sequentially.